Hi students, welcome to Simhas classes. Matrices. See here, we are going to discuss to find an eigenvalue and eigenvector of a 3 by 3 matrix. So this problem is so important problem. I will explain why it is so important when we do the problem. So this is the question. Find the eigenvalue and eigenvector of the matrix 6 minus 6 5, 14 minus 13 10, 7 minus 6 4. Let the given matrix be A. We know that eigenvalue is nothing but the roots of the characteristic equation. So for these kind of a problem, first we have to find the characteristic equation of the given matrix. So here the characteristic equation of A is given by determinant of A minus lambda is equal to 0. So what is the meaning of this? We know that lambda I, in the sense it is a scalar matrix, so whose diagonal elements are lambda, that can be obtained by lambda into unit matrix. What we get actually, determinant of A minus lambda I, in the sense 6 minus lambda minus 6 5, 14 minus 13 minus lambda, 7 minus 6 4 minus lambda. Determinant of this value we have to find. See, when we expand this determinant, we get a cubic equation in lambda cube. So that I can write lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0. Here we have to find s1, s2, s3. So s1 can be obtained by this formula, sum of the main diagonal of the elements. Here main diagonal, in the sense this is the main diagonal element. So sum of the main diagonal is 6 minus 13 plus 4. So this is equal to minus 3. S2 is nothing but sum of the minors of the main diagonal. So which means that we already noted that this is the main diagonal element. In this one, if I am taking first this diagonal element, then close this column and row, and we want to find the determinant value of this. So which is determinant of minus 13 10 minus 6 4 plus, then the next diagonal element is minus 13. So close this column and this row, then we have determinant of 6 5 7 4. The next element is this. See, close this column and the row, we get the determinant of 6 minus 6 14 minus 13. So I want to find the determinant value of this. So expand this, minus 13 into 4, it is minus 52, minus of minus 6 into 10, that is minus 60. So already one minus is there, so that will become plus 60. Here 6 4s are 24 minus 35 plus 13 6 are 78 minus 78. Here minus minus will become plus, 14 6 are 84. Now simplify this, it is minus 52 plus 68. This is minus 11 plus 84 minus 78 6. So 14 minus 11 we get 13. 14 minus 11 we get 3. Now S3 is nothing but a determinant of the matrix A. So I am going to find the determinant by expanding the first row. 6 into minus 13 into 4 minus 52 plus 60, minus of minus 6, so this will become plus 6. 14 4s are 56 minus 7 into 10 70 plus 5 into 14 6 are minus 84 plus 91. So now simplify this, it is 6 into 8 48. Here 6 into minus 14 minus 84, 5 into 7 plus 35. 5, which is equal to, so if you add these two, it is 83 minus 84, so we get minus 1. So we found S1, S2, S3. Therefore, the characteristic equation is lambda cube minus S1 lambda square. Here it is minus 3. So minus of minus plus. So plus 3 lambda square plus 3 lambda minus S3. S3 we got minus 1. So minus of minus 1 we get plus 1. So plus 1 equal to 0. So first we found the characteristic equation. The next thing is this, we want to find the root of this equation. We know that the roots of the characteristic equation is nothing but the eigenvalue. For cubic polynomial, there are methods to find the root. The simplest way is to use calculator. We can find the roots. But here it is of direct formula, a cube plus 3a square b plus 3a plus b cube. So I can write lambda plus 1 the whole cube. So where lambda is equal to minus 1, that is the another thing. If we know the cubic polynomial formula, you can apply it, and otherwise we can use the synthetic division. Synthetic division in the sense we have to consider the constant term and then we try to find the multiple of that term. So 1 can be obtained by minus 1 into minus 1, that is equal to 1, and 1 into 1 is equal to 1. Since here all terms are appear in positive sign, I am trying with the negative minus 1, which is a trial and error method. So minus 1 I write the coefficient of lambda cube lambda square constant value here, then 1, always this value be 0. So 1 plus 0 we get 1. 1 into minus 1, it is minus 1. 3 minus 1 is equal to 2. 2 into minus 1 is equal to minus 2. 3 minus 2, that is 1. 1 into minus 1, that is equal to 0. This I can write lambda square plus 2 lambda plus 1 is equal to 0, which can be written as lambda plus 1 into lambda plus 1 is equal to 0. From this we can find lambda is equal to minus 1 minus 1. Therefore the values that we obtained are, all three values are minus 1. Therefore the eigen values are minus 1 and minus 1. Next thing is to find the eigenvector for these eigenvalues. The eigenvector of a matrix A is given by A minus lambda I into x is equal to 0. A minus lambda I, how we will write it is 6 minus lambda minus 6, 5, 14, minus 13 minus lambda 10, 7, minus 6, 4 minus lambda to x1, x2, x3, which is equal to 0. Now multiply this matrix row into column. It is 6 minus lambda into x1 minus 6x2 plus 5x3 equal to 0, and 14x1 plus minus 13 minus lambda into x2 plus 10x3 equal to 0. 7x1 minus 6x2 plus 4 minus lambda into x3 equal to 0. So this is the homogeneous equations. We have to find the eigenvector by substituting lambda value in these equations. So now you take here all lambdas are minus 1. So I am substituting lambda is equal to minus 1. We get 6 minus of minus 1 plus 7. So 7x1 minus 6x2 plus yx3 equal to 0. Next 14x1 minus 12x2 plus 10x3 equal to 0. And this equation 7x1 minus 6x2 lambda, if you substitute minus 1, 4 minus of minus 1, this will become plus 5. So 5x3 equal to 0. look at these equations. The first and third are same. By taking 2 commonly out from the second equation, all 3 equations are same. So here all the 3 equations are same. If this is the case, I want to find the eigenvector, in the sense, take any one of x is 0, find it. Suppose if I am taking x1 is equal to 0, we get 6x2 equal to 5x3. This implies that x2 by 5 is equal to x3 by 6. This implies the eigenvector is 0, 5, 6. As a problem beginning, I told you why this is the important problem. I will explain when we are doing problem. See, here all eigenvalues are equal, but we get the homogeneous equal equation. That is why this problem is so important. If this is the case, and we have to follow the procedure what we are doing now. Next, you take x2 equal to 0, then apply in the first equation itself. It is 7x1 is equal to minus 5x3. This implies that x1 by minus 5 is equal to x3 by 7. This implies that we get the eigenvector is minus 5, 0 and 7. Now you finally, for the third eigenvalue lambda is equal to minus 1, you take x3 equal to 0, then we get, if I am taking x3 equal to 0 in this one, 7x1 is equal to 6x2. This implies that x1 by 6 is equal to x2 by 7. Therefore, the eigenvector is 6, 7 and 0. This is the answer for this problem. For more problem, subscribe and watch my channel. Thank you.